Hello everyone, and welcome back to this lecture on BSP 303, that is Digital Systems and Application. So we are going to start the fourth lecture today. In the last few three lectures, we have seen the basic of number systems, binary number systems, and the importance of binary number system in digital electronics. And we have also seen how we can do the number conversion from one type of number system into another type. Like, for example, we have seen the conversion from decimal number system to binary and binary to decimal. And then we have also seen the other conversion like octal to binary and then binary to octal, how we can do this conversion. So we'll continue our discussion, and today basically we'll try to focus on binary arithmetic, how we can do the addition and the subtraction of binary numbers. And then now why this is important is that later on we'll know that when we are designing the combinational circuit like binary adder and subtractor circuit, then we need to know this first binary addition and subtraction, the process. So we'll see this, but before that we'll first begin our discussion with the remaining conversion, whatever we left. That is, we have few more conversion to do from hexadecimal to binary and then binary to hexadecimal. Okay, so let us start the lecture, and let me share the screen first. Okay, so here we go. This will be our topic of discussion today, that is binary arithmetic, and we'll also try to see some of the how we can calculate the ones complement and twos complement of a binary number. So, but before that, let us try to first discuss, how we can do the conversion from hexadecimal to binary and then vice versa. We'll try to see this first, and then only we'll go to the binary arithmetic. So the topic which we will be focusing first is that, let me just note it down here, that is hexadecimal to binary conversion. So we'll just first try to see hexadecimal to binary conversion. This is what we are going to discuss first. So we'll take an example, and now it's not difficult if we have already learned earlier. We have already learned how to do the conversion from the decimal to binary. So if we remember those steps, then it won't be difficult. So let us say, for example, we have this particular number here, that is now the number would be in hexadecimal. So let us say we have this 2F9A. This is our number, and this is in hexadecimal number, and then we need to convert this into binary number with the base 2. So what we will do, see, in octal number conversion, each octal number is represented by 3-bit binary information, like each octal number. Okay, so similarly in this case also, in hexadecimal to binary conversion, what we will do, and in the last lecture I have already taught you how to draw the table for binary, decimal and hexadecimal. So if you can, if you learn how to do the table, how to draw the table, then it won't be difficult. So okay, let us come back to hexadecimal. So in hexadecimal to binary conversion, we will represent each hexadecimal number by 4-bit binary information. Okay, so you can just refer the table for more information. So now, if you have to represent this in binary number system, what we will do, each we'll start with 2. Now what is this 2 in, these 2 in binary is nothing but it is 0010, 0010. Okay, and then let us come back to now F. Now this F, if you guys remember, then it is nothing but it is 1111. So each bit will represent by 4-bit binary information. Each hexadecimal digit will represent by 4-bit information. Then we'll go back to 9 now. 9 in, sorry for that. So 9 in binary, it will be 1001, 1001, and then we'll go back to A now. A in binary, it is a 1010. So your decimal, your binary number is 0010, 1111, 1001, and then 1010. So this is how you can do the conversion. Okay, now see, if you have to come back to the reverse of this one, that is binary to hexadecimal. Okay, if you have to come back to the reverse of this one, that is binary to hexadecimal. I'm just writing in short hexadecimal. So what we would do, we would again divide the given, whatever the number, the given number by the binary number, into 4-bit information, and we'll start dividing. For the integer part, we will have to start dividing from the LSB. Okay, so let us take one example. I'm just taking the integer, binary integer only. I'm not taking the fraction here. So it is 10100 1101 0. Then we have 111. So this is our binary number. Now, what would you do? Let me just use different color here. So you would start from the LSB. Now you know that this is our LSB, the last one, isn't it? Start dividing this from the LSB into group of 4 now. In this case, you will have to do a group of 4, 1, 2, because you are doing the conversion from binary to hexadecimal. So hexadecimal numbers is represented by group of 4 binary numbers, digit. Okay. So here again 1, 2, 3, 4, and then here you have, this is 4. Now you have only 2 here, so you can always add as many zeros as you want to make this into a group of 4. Okay, so here what do we require now? We require 2 more zeros here to be added. So I'm just adding these 2 more zeros. Okay, now what is 0010? 0010 is 2. What is 1001? 1001 is 9. If you see that table, the master table, which I have shown you in the last class. So now 1010. Now what is 1010 in hexadecimal? This is A, and then 1111. 1111 is F. So in this way, very easily you can do the conversion. Okay. Now let us say, for example, you have to do the conversion of this fractional number. Okay, suppose I have any fractional binary number. Let us say I have this, for example, I have 0.000000000, then I have 4 ones. Okay, then 0101, 0101, then 101. Suppose you need to convert this fractional part into hexadecimal. Now you will have to start making the group from the left to the right in this way, after decimal point, for integers, for fractional. Okay, so we'll have to start making the group from here towards this side. This is one group, this is the second group, this is the third group, and now you see here you have only 01. So you are always free to add 2 zeros. So this number would be 0100. Okay. So what is 0001? Now 0001 is 1. 1110. 1110 is E in hexadecimal. Then you have 1011. 1011 is B, and then you have 0100. So 0100 is nothing but it is 4. So your hexadecimal is 1EB4. In this way, very easily you can do the conversion of hexadecimal to binary and binary to hexadecimal. All right. So now see, there are other conversion, like how would you do a hexadecimal conversion into octal conversion? Okay. So let me just tell you this very briefly before I move on to the next one. Hexadecimal to octal. Okay. Okay. So let us say this. Now you know that if you want to convert this hexadecimal to octal, do not directly try to convert this. Okay. So first, what would you do? If you are given any hexadecimal number, you first convert this hexadecimal. This would be your solution. You first convert this hexadecimal to binary. अभी आप लोग को मालूम है हेक्साडेसिमल टू बाइनरी कैसे कन्वर्ट करना है, ठीक है? In hexadecimal, every digit you will represent it by 4-bit binary information and you convert it into binary. Now, after this, because you want to convert this into octal, you will have to divide this binary again into a group of 3, isn't it? You will have to divide this into a group of 3, whatever number you will get here. First, you will write into a group of 4. You will write down all those total numbers. Then, since you are going to convert it into octal, now divide this binary into group of 3. Group of 3. And you know how to do that. I have already told you in the earlier lecture. After you divide this binary again into a group of 3, again you can do the rules. I mean, you know the rules for integers as well as fractional, depending upon whether your number is integers or both integer as well as fraction. You divide this into a group of 3, then you write down the octal number. Okay. Then the final step would be you write down the octal number. So this is how you would do the conversion of hexadecimal to octal. And you can do the vice versa also. You can do the conversion from octal to hexadecimal. Octal you will first write it in binary, ठीक है? जब आप octal को binary में लिखोगे तो हर octal number का जो digit होता है उसको हम 3 group में लिखेंगे. फिर उसी 3 group को आप क्या करोगे? You will convert it into a group of 4. Okay, starting from the LSB for integers. Okay, and for fractional part, you can start from left to right, like I have done it here. So in that way, like any number conversion, now I hope that the students can do any number conversion. And with this, we come to the end of this number conversion part. Okay, now what we will do, we'll continue our discussion and we'll try to see binary arithmetic. Okay, so in binary arithmetic, basically we'll try to see binary addition and binary subtraction. Okay, so what we will do, we'll see this first. Binary addition. All right, let us see this. So now you see, suppose you have 2-bit binary to be added. So I am just writing this augend here. Augend, then this is the number to which another number is to be added, and this addend is the number which is added to the first number, and then you will have sum, you will have carry, you will have sum, carry, and the final result. What will be your result? Okay, suppose I have 2 binary number, let us say 0 0 0 1 1 0 and then 1 1. Now if you do the addition of 0 and 0, what would be your sum? Sum would be 0. There is no carry generated, 0. The result is also 0. Now 0 and 1, if you do this addition, what would be the sum? 0 and 1, the sum is 1. There is no carry generated, 0, and the result is also 1. Okay, now 1 and 0 if you add, the sum would be 1. There is no carry generated, and then you will get the result also. Now if you add these two numbers like 1 and 1, now your result is actually 1 0. ठीक है, result हम लोग को 1 0 मिल रहा है. 1, this is you just note it down this step. 1 and 1, you will get 1 0 as the result. So the result is actually 1 0. Now what would be the sum? Sum is this 0. Okay, sum is 0, and then what is the carry? Now you see that a carry is generated here, 1, isn't it? So I'm just going to write a carry here. So for 1 1, you will get the result as 1 0, and 1 0 is the result. I'm writing the result here, and 0 is the sum, and 1 is the carry. So when you add 1 and 1, you will get 0 as the sum. Okay, now keeping this in mind, you can sorry, you can see different examples. You can try to add 2 different numbers, binary numbers. Okay, so all right, let us go to the next slide. So where I can show you the addition of, for example, I can show you one example, that is, let us try to add this 1 0 1 1, and then let us try to add these two. 1 1 0 0. So 1 and 0, if you add, the sum is 1. 1 and 0, if you add, the sum is 1. 0 and 1 also, the sum is 1. Now 1 and 1. What is 1 and 1? The sum is 0 and there is a carry generated. So in this way, you can do the addition. Okay. So this is your carry. Now let me go and show you the next addition. Like suppose I wanted to add 0 1. Suppose I wanted to add 0 1 0 1 to 1 1 1 1. Okay, fine, ठीक है. Now 1 and 1 1 1 को ऐड करते हैं तो हमको रिजल्ट क्या मिलता है 10. इसमें से सम 0 होगा, सम 0 होगा, और this one will go to carry. This one will be as a carry which is generated on the top. Okay. Now you add these two again, 1 and 0. Now what is 1 and 0? 1 and 0 is 1. Again you have this 1 and 1. 1 and 1 is again 1 0. So 0 would be here, carry would be here. Now 1 and 1. What is 1 and 1? 1 and 1 is, let us try to add these two first. 1 and 1. 1 and 1, the result is 1 0. You have the sum as 0 and carry is already generated. So this generated carry, let me write it down here. And what is left out? Left out is 0. Now this 0 and 1 is what? 1. Now the next step, 1 and 0. 1 and 0 is 1. The sum is 1. And then again 1 and 1 is, sum is 0. And again 1 carry is generated. Okay. So in this way, you can do this addition. So the final answer is 1 0 1 0 0. So in this way, you can see, I mean, you can see different examples. You can just practice some more questions, more example, then it won't be difficult. Okay. So in that way, like you can add, here we are adding only 2 numbers. You can add 3 numbers also. But just remember one thing, that whenever a carry is generated, like in this case, in this particular case, let us see this. Let me repeat this. Whether you are adding 2 numbers or 3 numbers, whenever your carry is generated, for example, in this case, as immediately in this step, a carry is generated, isn't it? So immediately that carry I am writing here. And in the second process, if another carry is generated, you will write on top of this one. There can be 2 carry as well. In one step, there can be 2 carry as well. Okay. So in this way, you can do this binary addition. Now let us go forward and see the binary subtraction, how we will do the binary subtraction. So for that also, we will first try to write down the table, subtraction table. Okay, let me just write down here, binary subtraction. Okay. Let me write down the table. In this table, we have minor end. That means the number from which another number is subtracted. That is known as minor end. And then we have subtrahend. The second number, the number which is subtracted from the previous number, it is known as subtrahend. And then we will have 2 things here. One is the difference, and one is borrow. Okay. Now in a subtraction, we will not have carry, we will have a borrow. Whether you need to borrow any number to subtract one number from the other. Okay. That is why we will have a borrow here, not not the difference. Okay, fine. So not the carry, you will have the borrow. So let us have 2 numbers. First one 0 0 0 1, and then 1 0, and then you have finally 1 1. So if you do the subtraction of 0 minus 0, the difference is 0, and you did not take any borrow to subtract. You can subtract this 0, so the borrow is also 0. So now 0 minus 1. See here, 0 minus 1. You cannot subtract this 0 minus 1. So what would you do? You would take a borrow. Okay, you would take a borrow. So it is just like, okay, you will take a borrow, and then the difference of these 2 is nothing but it is 1. You will take a borrow, and then the difference of these 2 is 1. Okay, so 0 minus 1 is, you will have a borrow 1, and then you will have a difference also 1. Okay, so now 1 minus 0, you can do the subtraction. 1 minus 0 difference is 1, and you did not borrow anything, so 0. Fine. And now 1 minus 1. 1 minus 1, you have difference is 0, and then the borrow is also 0. Okay, so this is the difference. I mean, if you do the subtraction of any two numbers, you need to keep this in your mind. Okay, the second step, this one, okay, you need to just note it down. Others are not that much, but in this case only a borrow is generated, because you cannot do the subtraction from 0 to 1. So what you need to do, you need to borrow a number here, and then the difference of these two would be 1. Okay, all right, so let us see some example. We'll try to see some example here. Let me go to the next one. The example is, suppose you need to subtract 1 0 1 1. Okay, you need to subtract 1 0. Okay, it's not the number. So 0 1 1 0. So let us say you need to do this subtraction. So here, so there is no problem. 1 minus 0, that is difference is 1. 1 minus 1, difference is 0. 0 minus 1. अब इसमें नहीं होगा difference. ठीक है, तो हम क्या करेंगे? Now what would I do? A borrow is generated from the next. Next one is here. Here you have a 1. Okay, a borrow is generated, and then what is the difference of 0 minus 1? Okay, then it is 1. I get a 1 here, then 0 and 0, you will get 0. So the difference is 0 1 0 1. Okay, so now in this third column, what is basically happening? You see, in this first, second, and third column, since we cannot subtract 1 from 0, we borrow a 1 from the fourth column to the left. Okay, we borrow a 1 from this fourth column. Then we write hence we put down the 1 in the answer and change the 1 to the fourth column to 0, and this 1 to 0. Once you borrow, it will become all right. Okay, so this is the case. Now this will be your answer in this case. So in this way, like, you can try different subtraction actually. Okay, you can try to see different subtraction. So some more problems can be seen here. Right? So this is about binary addition and subtraction. Now, before we actually conclude today's session, I would like to give you a glimpse of like 1 complement representation and 2 complement representation. Okay, you can also do the subtraction using 2's complementary method. Okay? That is why I mean these are important. So let us study how would you complement 1's complement. This is quite simple. 1's complement of a binary number. Right? Now, in binary number, if each 1 is replaced by 0 and each 0 is replaced by 1, then the resulting number is known as the 1's complement. Okay. Now, if any one of these number is positive, then the other is actually negative. 1's complement का मतलब क्या है? अगर if one of the number is positive, then the other should be negative. Okay, with the same magnitude and vice versa with both of them. Okay, and for positive or negative number, you know that MSB, which is the most significant bit, MSB is 0 for positive numbers, which I have discussed in the last lecture, and then it is 1 for negative number. Okay, so how would you calculate a 1's complement? For example, let us see. Suppose I have this number. You will just need to change. Suppose I have 0 1 1 0 1 1 0. If the question is to find the 1's complement of this, you will just need to change this. I mean, this 0 to 1 and 1 to 0. Okay. All the 1's you will change it to 0. This 1 would change to 0. This 0 would change to 1. This 1 would change to 0. this 1 again would change to 0, and this 0 would change to 1. So this is the ones complement representation. Similarly, if any decimal number is given to you, you can represent that using your the ones complement. For example, +7. अगर +7 आपको 1 complement may represent, let us say this is decimal, what would be -7? Okay, this is actually the meaning of ones complement. If one is +7, the others would be -7. So what is +7 actually? +7 is, you know, that if you see the binary table, you will find that it is 0, 1, 1, 1, isn't it? Because this 0 at the end, actually, it represents the positive, and the 3 bit, it represents the magnitude of the number 1, 1, 1. So this is how you can write 0, 1, 1, 1 to the base 2. Now, if you find the complement of this one, okay, 1 का complement क्या होगा? 0. 1 का complement 0. 1 का complement 0, and then you will have your number 1. So these 1, 0, 0, 0, 0, this is nothing but this is your -7. Okay, so in this way you can write like all the other number as like +8 -8, +15 -15, if you're writing the inside magnitude representation as well. But you remember this step, to calculate the ones complement, you will just convert 1 to 0 and 0 to 1. Okay, so I think here I have made some mistake. Okay, here I have made some mistake. This the first one, 0, it should be 1. Okay, so the complement of 0 is 1, 1, 0, 1, 0, 0, 1, then others are okay, I guess. So this is how you will calculate the ones complement. All right, now let us go and see. Before we conclude today's section, I will try to tell you how would you calculate 2's complement. Okay, one simple rule is you need to just add 1 to 1's complement. You need to just add 1 to 1's complement, then you can calculate the 2's complement. For example, you can take any number. Okay, you can take any number, let us say 0, 1, 1, 0, 1. You need to calculate the 2's complement of this one. So first, what would you do? You will find out the 1's complement. Okay, पहले हम क्या करेंगे, इसका 1's complement निकालेंगे. 0 का 1 होगा, 1 का 0 होगा, 1 का 0, 0, 1, and 1, 0. Now you need to add 1 to this 1's complement. So what would I do? I would just add 1 to this 1's complement. So 0 plus 1 is 1. Then you have all these numbers here. So this is your 2's complement. Okay, you just need to add 1 to the 1's complement. There are other shortcut method also to do the 2's complement. For example, let me just try to tell you one method. Like the another method is, the first rule is, okay, if the LSB of the number is 1, if the LSB is 1, okay, least significant bit, like in this particular case, let us take the number to be 1, 0, 0, 1, 1. If the LSB of the number is 1, then the 2 complement of this number is obtained by changing each 0 to 1 and each 1 to 0. Each 0 to 1 and each 1 to 0, except the least significant bit, which is this itself. Okay, you need to just change each 1 to 0 except the least significant bit. For example, here in the first method, like except this one, except this LSB, you need to just change this 1 to 0, and you need to change this 0 to 1, you need to change this 0 to 1, and you need to change this 1 to 0. Okay, now this is the case when the LSB is 1. Now if another case, if the LSB, if the least significant bit is 0, what would you do? Okay, the method is that if the LSB is 0, then its 2 complement is obtained by scanning the number from right to left. Okay, by scanning the number from LSB you just need to scan the number from LSB towards the MSB, and then you retain all the bit up to up to the occurrence of the first one, and then complement all other bits. Okay, let me just give you some example. For example, for this second rule, let me go to this number. Suppose I need to calculate the 0, 1, 1, then we have 0, 0, 1, 0, 0. So in this case, you see the LSB is 0. Okay. Now in this case, what would you do? You need to scan all these numbers from LSB towards the MSB until the occurrence of the first one. You see, while scanning, first one is up to here. So you will have to stop the scan here. Now, after this, the occurrence of the first one, then only you interchange this. After this, you interchange this 0 to 1, this 0 to 1, this 1 to 0, this 1 to 0, and then this 0 to 1. So these are the two shortcut methods. So your number, your two complement would be 1, 0, 0, 1, 1, and this would be as it is 1, 0, 0. So if the LSB is 1, okay, if the LSB is 1, then you need to just, I mean, if the LSB is 1, then except this LSB, all other should be converted into 1 to 0 and 0 to 1, and then you will ultimately write this LSB 1. Now, if the LSB is 0, then you will have to start scanning the number from LSB towards the MSB until you get the first one. So in this case, you get the first one in this, the third column, let us say, okay, the third one. Then up to here, you will retain as it is. Then after this, you will change it 0 to 1. Okay? So these are the two shortcut method. I mean, how would you convert the one complement to two complement? Okay, and so, all right. So with this, we come to the end of today's discussion. So we will stop here. So, and with this, actually, we have learned, I mean, all the number systems. Okay, we have learned the number systems, and then which is important in, I mean, when we are studying digital electronics. So we have also seen the conversion of the number system, and then, I mean, we have also seen how to do the binary arithmetic, that is the binary addition and the binary subtraction. Okay, so in the next class, I mean, from the next lecture, we will try to see the logic gates. We'll try to start with the basic logic gate. Okay, that is what we will study from the next lecture. So thank you everyone for joining, and see you all in the next lecture again. Thank you.